All right, welcome everyone. Let's continue our work with probabilities and let's see how we can apply probability to answer some statistical questions or analyze statistical questions. And so the motivating question for this video is going to be whether there is an association between whether or not a melanoma skin tumor is ulcerated and the long-term survival of the person. So a skin tumor is ulcerated means that the tumor has been growing under the skin and breaks through the skin and creates a wound. So typically that would mean that the skin tumor is longer along its evolution than one that gets surgically removed before it's ulcerated. And so the data set that we're going to use to analyze this question is in a data set called Melanoma, which is in a package called boot in R. So a link to this Colab notebook is provided in the description of this video so that you can run the code and follow along with the analysis we're doing in the video. So let's first load the boot package so that we can access the melanoma data. And if you're curious about what is in the melanoma data, we can run question melanoma, and that's going to open up the help documentation, and you can see where the data is from, how large the data is, what are the variables in the data set, and so on. So I'm not going to get into all of that in this video. I want to mostly just focus on how we're going to analyze the data in this data frame. So I'm going to close this. And a good initial way to investigate the data is to run a summary command and take a look at numerical summaries of all of these variables. And we can see that everything here is being stored numerically. We can see that with a structure command as well. So even variables such as sex and ulcer and status, which should be categorical variables, these are coded with numbers and they're being read as a numeric variable. So we're going to go through some cleaning pretty quickly because, again, that's not the focus of this video. But the two variables that we're going to really want to focus on are the status variable, which tells us whether the person died from melanoma through the course of the study, whether they survived at the end of the study, or whether they died from other causes. And the other variable that we want to consider is we want to see whether there's some condition between survival and whether the skin tumor that was removed, whether it was ulcerated or not. And again, these are being coded with numbers and they're being read as numerics. So we're going to quickly just clean up the data. So the first thing we're going to do is just pull off the data we're interested in. So there were some people in this study that died from other causes, and their status was therefore coded as 3. So this means we are going to just keep the observations in the melanoma data set that had status not equal to 3. So that's what this exclamation point equal sign means. So essentially, that's just going to keep status 1 and 2, which were the people that died from melanoma or survived. And the two variables that we're going to keep are going to be the status variable and the ulcer variable. We don't need the rest of them. I'm going to run this command. We're not going to see any output. It saved everything to this new data frame that I called skin. And now we can summarize that resulting data set. And we can see here we've just kept these two variables. And status group, we only have 1 and 2. And status group 3 has been excluded from this data set. And so all of these numbers, they're not very descriptive in terms of the status and the ulcer value. So this code cell below is just going to replace people that are coded with a 1 for status with a more descriptive string of characters died. And so we're just going to describe each of these values more in terms of the context. We've written over the values that were originally in our skin data frame. And now let's check out the result of this previous code cell has changed all of these numeric data types to character data types. So this is not a really helpful summary. Recall, categorical variables we want to store in R as factors. So finally, this command over here is going to convert status and ulcer variables to factors. So this means R is going to treat these as categorical. So when we run a summary on the skin data frame, we can now see counts. There were 191 people in this data set that are remaining in this data set. And out of those 191, 134 were alive at the end of the study. 57 died from melanoma. And 108 of them had ulcerated skin, did not have an ulcerated skin tumor. 83 of them did have an ulcerated skin tumor. And so these totals are kind of independent of each other. We're just getting the total of status and the total of ulcer. But we would like to know whether there's some association between these two variables. And so a two-way table is a useful way of kind of summarizing two different categorical variables to analyze any relation between the variables. And recall in R, the way that we can create a frequency table, a two-way table of counts, is using the table function. So here we're going to create a two-way table for the status and ulcer variables in our data frame skin. And then we're going to save it to a freq table. And now I'm going to print that output to the screen. So now I'm looking at a two-way table of skin. And so, for example, this 92 is telling me out of the 191 people in this study, 92 of them were alive when the study ended, and they did not have an ulcerated skin tumor removed. Their skin tumor did not have any ulceration. So from each of these numbers, we're looking at an intersection that both of those events were satisfied, that both they had an ulcerated skin tumor, for example, this 42, and they were alive. If I want to see whether there's some association, whether people that don't have ulcerated skin tumors, whether they were more likely to survive, I don't just want to look in the survive column, or excuse me, row over here and say that, look, there were 92 people, that's more than the 42 over here. So not having an ulcerated skin tumor means they have a better chance of being alive. And that might be the case, but that's a little misleading. We need to be careful because the two groups that we're comparing, the group of people that had a skin tumor that was not ulcerated, that's 108. And that's a bit bigger than the other group that had ulcerated skin tumors. So we're almost comparing apples to oranges. One group has a different size to the other, so we don't just want to compare totals in these two groups. I don't just want to compare the 92 to the 42 in the two-way table. Okay, and so I will again point you to, there is a solution Colab notebook to go along with this notebook that we're working with. And down below here, you can kind of see the solution over there. But I'll let you check your work with the solutions that are linked in the description of this video. So question 3 is asking us to use the table in this frequency table. So I'll print that out above so we have it close to the question to calculate a number of probabilities from this two-way table. So if I denote the event that the person had an ulcerated skin tumor with a Y, then in part A, we want to calculate P of Y. So I can take the total number of people in event Y, which is had an ulcerated skin tumor. So that's the 42 and the 41. That's the total from this column, 83. And I divide that by the total number of people remaining in our study, and that's the 191 people. So I get 83 out of 191. So P of Y winds up being 0.4346. In part B, we want to calculate the probability that a person was alive at the end of the study. So if we denote A event that the person was alive with an A, then P of A would be the total of people that were alive. So that's the 92 plus the 42 for 134. And we divide that by the 191 people, the total in the study. And that gives us P of A is 0.7016. In C, we're asked to calculate the probability that the person both had an ulcerated skin tumor and was alive. So that's like an intersection of two events. So in probability notation, we would write this as intersection, P of Y, intersection symbol. That's what this, this cap is with A. So P of Y intersect A is going to be, well, the total number of people that had an ulcerated skin tumor and were alive. That's this cell in the two-way table. So that's this 42 people out of the grand total 191 people. That gives us a proportion of 0.2199. And in part D, this is asking us for the probability that a person had an ulcerated skin tumor or was alive. So that we denote with a union symbol. So that would be P of Y union, that's this cup symbol, A. And in this case, we now would take a look at all of the people that had an ulcerated skin tumor. So that was the 83 people that we counted from this column. We add that to all of the people that were alive, and that's the total from this alive column. So that was the 134, but we just double counted these 42 people in both of those totals. So we don't want to double count them, and that's why we're going to subtract 42. So our numerator is going to be the 83 plus the 134 minus the 42 people that were just double counted. And we divide that by the grand total of 191. And that gives me a proportion of 0.9162. Okay, and finally, this last question, E, this is what we call a conditional probability. And so we're no longer considering all people in this study, not all 191 people, but now we're considering the subset of people that had an ulcerated skin tumor. So that's just the people in this second column. So now we're saying out of these 83 people, so our denominator has changed from all 191 to just the 83 people in the second column that had an ulcerated skin tumor. So out of those 83 people, how many of them were also alive at the end of the study? And that's 42. So we take this 42 and we divide by 83, and that gives us a proportion of 0.506. And the notation that we use for a conditional probability is we put a little vertical bar inside the probability, and to the right of that bar, we put the given condition, which in this case was Y, and to the left of that bar, we put the other event, and that was that they were alive, so that's the A. And so this is almost like a fraction that we can read. The denominator is changed to the event, the total of the event that is to the right of that bar. And you can check the solution Colab notebook to see how I entered those fractions in R to get those proportions. And they're typed out a little nicer, the solutions in the solution notebook. Okay, so question 4 is asking us to come back to the original statistical question was, do we believe, based on this data, that people with skin tumors that are not ulcerated are likely to survive longer compared to people with ulcerated skin tumors? To answer this question, we want to take into account the different sizes of these two groups, namely the people that had ulcerated skin tumors, that was 83, compared to the 108 people whose skin tumor was not ulcerated. So we calculated one of those relevant probabilities in 3E, which we said out of the people that had ulcerated skin tumors, the proportion of them that were alive at the end of the study, that was the proportion of 0.506. And let's compare that to the conditional probability that the person was alive at the end of the study, given that they did not have an ulcerated skin tumor. We'll call that N. So that conditional probability, let's take a look at the frequency table that we would want to use to calculate that. So now we're taking a look at just the group of 108 people that did not have an ulcerated skin tumor. And out of those 108, 92 of them were alive. So that's the 92 divided by the 108 I can see over here, and that winds up being 0.8519. And so I'm just gonna paste the solution from the solution notebook over here. And so we can see that out of the people that had an ulcerated skin tumor, about 50% of them were alive at the end of the study. Out of the people that did not have an ulcerated skin tumor, about 85% of them were alive when the study concluded. So this difference seems to be pretty large. So this seems to give us some evidence that, yeah, people whose skin tumor was not ulcerated, they tend to be surviving longer than the people whose skin tumor was ulcerated. Okay, so while we are on this topic, it's a good occasion to bring in proportion tables that we've seen in our earlier. So I could have performed that analysis above using a prop table. The input into a prop table, recall, is a table itself. So you would first need to create a frequency table, such as the one that we did above, this two-way table that we've saved and stored in freq table. And depending on whether we put no second option or a 1 or a 2, recall this gives us proportions relative to different totals. So this first one would give us all of the probabilities relative to the same grand total of 191. Putting an option of 1 is going to give us proportions relative to the total in each row. So in other words, proportion out of just the alive people, and then the proportions calculated for just the people that had died. And option 2 is going to calculate these proportions relative to the column totals. So relative to the 83 people over here and the 108 people over here. So this next question is saying, well, if we wanted to use a prop table to get directly to the two conditional probabilities that we compared up here, well, these two probabilities are relative to the column totals. The total from this column and the total from the present. So I'm going to use option 2 with the frequency table. I'm going to just paste that down here. So we're going to create a prop table from our previous table relative to the column totals. And we'll take a look at the output. And from this output, we can see exactly the two conditional proportions over here, that out of the people that did not have an ulcerated skin tumor, 85% of them were alive. Out of the people that did have an ulcerated skin tumor, 50% of them were alive at the end of this study. Seeing these bar plots below, so if you want to play around with this code, here's a nice way that you could use a stacked bar plot to convey those relevant conditional proportions in one nice graphic. So here we have, out of all of the people that did not have an ulcerated skin tumor, we can see about 85% of them were alive. That's the red bar, and the rest had died. Compared to those that did have an ulcerated skin tumor, the proportion that were alive in red over here was about 50%. So it's much smaller compared to the group that did not have ulcerated skin tumors. Okay, so that's a wrap on applying some probability and using two-way tables to analyze statistical questions.